Hello, everyone, and welcome to the Geostrategic Podcast. Thank you for watching or listening to the podcast. Right now, inside Russia's high-security missile factories, the machines building the weapons aren't Russian. They're German, they're Japanese, or Swiss. Despite the global sanctions you've heard about, 15 major military plants are still operating with high-tech Western tools that technically don't exist in Russia. Today, we're exposing the 66 units of foreign tech, from CNC centers to precision lathes, that are fueling this war machine through a map of betrayal that no one is talking about. This is a massive security loophole, and I want to hear from you. Is this a failure of politics or a secret business deal? Drop a comment below. Nothing is off limits here. While you're down there, hit that like button and subscribe to join the investigation. Let's get into the data. So our mission for this deep dive today is to rapidly synthesize the latest news and updates, so we can truly understand the geostrategic implications of this massive hardware loophole.
Yeah, because it really does change everything we thought we knew about economic warfare.
Exactly. I mean, we're looking at 15 distinct military-industrial enterprises here. Yep. And the latest updates show they're operating completely outside the Sanctions coalition. They're utilizing 66 very specific units of foreign technological equipment.
Right. And what's fascinating here is the sheer level of sophistication of these 66 units. We're not talking about like basic power drills or hand tools here.
Right. No hammers and wrenches.
Exactly. We're talking about high-precision lathes, advanced milling and grinding machines, and these multi-axis CNC machining centers.
Which are basically robots, right? Not just a saw on a table.
Yeah, that's exactly it. They're highly advanced robots that carve complex metal shapes from solid blocks with, microscopic precision. And the latest info also shows systems for printed circuit board production, vibration test stands, and extreme temperature chambers.
Oh, wow.
Yeah, and their origins read like a who's who of global precision manufacturing. So Germany, Japan, Switzerland, Taiwan, Austria.
Okay, let's unpack this, because I think, it's really easy to hear a list of industrial equipment, lathes, milling machines, and kind of lose sight of what that actually means on the ground.
Totally.
I mean, trying to manufacture modern weaponry without these specific machines is like trying to build a state-of-the-art smartphone using only blacksmith tools.
Right, yeah.
It just cannot be done.
No, not at all.
But I have to push back here for a second. Why does a massive military power even need an Austrian milling machine? Like, why can't they just build their own CNC machines to cut their own metal?
Well, that comes down to the brutal physics of modern warfare. It's all about manufacturing tolerances. Modern military tech requires tolerances measured in fractions of a millimeter,
right?
Sometimes down to the micron level. Because think about the environment a cruise missile actually operates in. It's traveling at supersonic speeds, so the aerodynamic stress is just immense.
Yeah, the friction alone would be crazy.
Exactly. So if a domestic lower quality lathe leaves even a tiny, like almost invisible imperfection on a machined titanium fin, the friction at Mach 3 will heat that imperfection up. It causes a microfracture, and then it literally tears the missile apart mid-flight.
Wow. So it's not just shaping the metal, it's shaping it perfectly so physics doesn't rip it to shreds.
That is the core issue. And the same logic applies to the electronics. Those vibration test stands and the Swiss temperature chambers, they are used to simulate the violent G-forces of a launch and the freezing high-altitude environments.
So if you don't test the circuit boards in those exact simulated conditions,
your guidance system freezes at 30,000 feet and your missile misses the target by miles. Without German lathes to cut the metal flawlessly and Swiss chambers to test the electronics, you don't have a reliable missile. You just have a very expensive paperweight.
Right.
This tech is the sole reason their defense industry can maintain its production rates and adapt to a prolonged war under intense international pressure.
Okay, so they have the German lathes to cut the metal and the Swiss chambers to freeze test the circuitry. But where are they actually doing this? The latest news doesn't just say somewhere hidden. It pinpoints specific unsanctioned facilities, right?
Yes, very specific ones.
We're looking at the Tambov Electronpribor plant, the Volsky electromechanical plant, and JSC Orbita. And they aren't churning out like helmets or boots. They are actively manufacturing critical components for the 9M727 cruise missiles.
Oh, right, the 9M727, which is a vital piece of hardware. It's a key component of the Iskander operational tactical system.
And for anyone who doesn't read military spec sheets all day, the Iskander isn't just a standard rocket, is it?
Far from it. It's one of the most advanced ballistic and cruise missile platforms in operation today. It's designed to evade modern missile defense systems, perform evasive maneuvers, and strike high-value targets with pinpoint accuracy.
And it's dual capable, too.
Exactly. It can carry conventional payloads to level reinforced bunkers, or it can be fitted with nuclear warheads. And if we connect this to the bigger picture, the geostrategic implication here is massive.
Because it completely bypasses the sanctions.
Right. The whole point of international economic sanctions is to bottleneck weapons production, to reduce their effectiveness on the battlefield. But the ability to produce Iskander missile components using global technology directly undermines that goal. It effectively nullifies the economic pressure.
Yeah, if the factories are still running at full capacity, the sanctions coalition is essentially fighting a ghost.
Exactly. The leverage just doesn't exist at the manufacturing level.
So what does this all mean? I mean, wait, I'm stuck on the logistics here. If these facilities aren't sanctioned, how exactly are they getting their hands on Austrian or Taiwanese tech during an active war? You're telling me someone buys a 5-ton Austrian milling machine, slaps a sticker on it that says washing machine parts, and Border Control just waves it through.
I mean, you're not far off. The latest news points directly to the mechanics of a shadow supply chain, and it thrives on a concept called dual-use classification.
Dual use, meaning it can be military or civilian.
Exactly. The global mechanism of trade isn't built to play detective on every shipping container. A highly advanced CNC machining center is inherently dual use. It can carve parts for a supersonic cruise missile, yes, but it can also carve parts for civilian jetliners or medical MRI machines.
So it's a lack of end-user control. They buy it for a hospital, maybe, but it goes to a weapons plant.
Yep. It slips through via third states and secondary markets. A front company in a neutral, non-sanctioned state purchases the equipment. On the customs forms, it's formally designated for the civilian sector.
So the German manufacturer ships it out, thinking it's totally legit.
Right. Export controls check the paperwork, see a civilian buyer, and approve it. But once that 5-ton machine hits the third state, it enters a secondary market. It's quietly loaded onto a train or a truck, crosses into Russian territory, and gets redirected straight into a military plant.
Wow. But if you're listening right now, you're probably wondering what I'm wondering. Why don't the countries manufacturing these multi-million-dollar tools just put GPS trackers inside them? Like, I can track my phone to a coffee shop 3 towns over. Why doesn't an Austrian firm know their machine is in a Russian weapons plant?
It's a brilliant question, but there's a huge blind spot in international logistics. First, legally, demanding a 247 GPS uplink can violate corporate espionage laws and proprietary data protections.
Oh, right.
Second, logistically, these machines operate deep inside heavily shielded, concrete-reinforced military bunkers. GPS signals simply don't penetrate.
That makes sense. Plus, the smugglers probably just rip the trackers out anyway.
Exactly. The shadow supply chain expects it. The moment that machine arrives at the proxy warehouse, technicians strip the casing, physically remove the telematics modules, and the trail goes completely cold.
Man. But there is a countermeasure being discussed, and this is where it gets really interesting. The latest updates from Ukrainian Defense Intelligence propose a completely different approach.
Yeah, it's a fascinating pivot.
Right. Instead of playing whack-a-mole, trying to intercept multi-ton industrial machines disguised as civilian goods, the strategy is to target their lifelines. You restrict the spare parts, the specialized technical fluids, and the software updates.
And this raises an important question about the fragility of this Russian advantage. We tend to think of heavy machinery as indestructible blocks of iron. Just plug them in and they run forever.
I mean, they look pretty indestructible.
They do, but modern high-tech equipment is incredibly fragile without its specific support ecosystem. These machines require proprietary technical fluids like highly specific coolants and synthetic lubricants just to operate.
Let's break that down. What happens if they just go to a local refinery and use, like, off-the-shelf industrial oil? Why do they need Austrian fluids?
It goes back to the physics of cutting metal at microscopic tolerances. When a multi-axis CNC machine is carving a titanium missile fin, the cutting head is spinning at like 10,000 to 20,000 RPMs. The friction generates intense heat. If you use a generic oil, the heat expansion of the metal changes by a fraction of a millimeter, completely ruining the part. Worse, the generic oil just breaks down under the sheer thermal load.
Oh, so the machine would overheat.
It would literally melt its own gears and cutting heads into slag within 3 minutes of operation.
That is an incredible image. So you literally starve the machine of the one fluid it needs, and it destroys itself. And the software aspect is even more critical, isn't it?
Oh, absolutely. These aren't manual machines from the 1950s. They're massive, heavy-duty computers that happen to have cutting tools attached.
Right.
They rely on incredibly complex software, and they often need to ping a manufacturer's server for license renewals, cryptographic key validations, firmware updates.
So if the machine's internal computer doesn't get that digital handshake from the manufacturer,
The safety protocols kick in, the spindle lock refuses to disengage, the operating system just freezes.
so you don't even need a covert ops team to blow up the factory. You just brick the machine remotely.
The Ukrainian Defense Intelligence analysis is spot on here. Without those technical fluids and software lifelines, these multi-million-dollar machines quickly become bricked. They're just useless, heavy monuments of iron. Enforcing secondary market controls on those fluids and conducting usage location inspections through software audits could effectively sever this industrial lifeline.
It fundamentally shifts the battlefield, doesn't it? From customs checkpoints to digital networks and specialized chemical supply chains.
It really does. It highlights a massive vulnerability.
Yeah. If a factory can be paralyzed because a server in Germany refuses a software handshake or a shipment of synthetic coolant from Austria gets flagged, it changes everything. If software updates and technical fluids are the ultimate Achilles heel of these high-security weapons factories, could the future of geostrategic warfare rely less on explosive payloads and more on digital kill switches hidden inside everyday industrial machinery? It's definitely something to think about as this all evolves. Thank you, everyone, for watching or listening today. We warmly invite you to check out and listen to the other podcasts.
See you in the next one.